Hello guys, welcome to Little Neutron. In this tutorial, we will learn how to make a highly stable drone, one that can even challenge the DJI drones. So for that purpose, we will be using DJI NAZA-M V2 flight controller. As you can see, no one is controlling it. Still, the drone is extremely stable in one position. So without wasting any more time, let's get started. We will be using X500 frame. This frame can also be configured as a coaxial octacopter. In my next tutorial, I'll be upgrading it to coaxial octacopter. For now, let's enjoy today's tutorial. These are all the parts that I received with the frame. First, we will assemble the arms. We will be using 2312 1150 kV T motors. Keep the motor wires outward so you can pass them from the carbon fiber rods. Here you can see that I have replaced a screw. This is because the screw that comes with the frame was touching the wire. That can damage the motor winding, so I replaced it with a smaller one. Follow the same procedure to assemble this frame and make sure to tighten every screw. Follow the same procedure to assemble the remaining 3 arms. Now we will start assembling the base plate. Now let's attach the landing gears to the base plate. We will be using 4-in-1 30 amperes ESC. Attach the ESC to the base plate using double tap. Place it in the very center of the base plate so no arm will touch it. Make sure it sticks hard. As already told, I will be using DJI NAZA-M V2 flight controller. This is our main flight controller. This is the GPS module, power module that supports up to 6S. And this is our LED module. It allows you to connect your flight controller with our laptop. It also has an RGB LED that is used as an indicator. This is a really very stable flight controller. Carefully place the power module on the base plate using double tap. These are the wires for the motors, and these two wires are the input of power module, so directly attach them with our ESC input. Let's look at the wiring. This is the LED port and this is the power module port, and all these pins are for the ESC output. It allows you to connect 8 motors at a time. This is the receiver port. Here is the power module port. Connect it just like this. You will also see a servo connector coming out from the power module. It will be connected on X3 port. As you can see on the power module and flight controller module both have an X3 port. The GPS port is mounted on the power module. Here you can see. Just connect it like this. Here is the port for LED module. Connect it just like this. As you can see that these wires are too short and cannot directly connect with the motors. So for that we will use these extended cables. This is the top plate with anti-vibration pad. Carefully pass all the wires from the arms. Now this is a very important part. Take a scale and measure every and make sure all the motors have same distance from the base plate. Now take a 90-degree scale and make sure all the motors are perfectly facing the top side. After that, tighten all the screws. Now connect the motor wires with ESC wires. We will be using 6300 mAh 4S LiPo battery. Attach the LiPo battery to the drone. Checking the direction of the motors, we will be using servo tester. Connect the ESC wire one by one to the servo tester and check the direction of the motor and follow this diagram. Match the direction of the motors with this diagram. Then follow this diagram to change the direction of the motor. As this is the front direction of the frame and this arrow represents the front direction of the flight controller. Make sure the front direction of the flight controller must be in the front direction of the frame. Attach the flight controller on the anti-vibration pad using double tap. Place it extremely straight so we can get a stable flight, as this thing matters a lot. This is the GPS stand. I tried a lot, but this part wasn't passing from the road. So I decided to use a drill machine. Now it's perfect. Tighten all the screws and place it on the top plate. This is a piece of circular double tape that is mostly used for the GPS module to place on the stand. As you can see, the GPS module also has an arrow. This arrow represents the front direction, so place it in the front direction as flight controller. This is our LED module. Connect the LED module to the base plate using double tap. Complete the wiring as I explained. You can also follow these diagrams. I will provide a link for this in description below. Carefully pass all the wires. Now we will assemble the battery holder. Now this is the final look of our frame. It looks very beautiful. For controlling the drone, we will be using FrSky Taranis QX7 with FrSky XM Plus receiver. This receiver supports up to 16 channels of S-bus, which is more than enough for us. This is the X2 port where our receiver will be connected. Carefully pass the wire of the receiver and connect it to the X2 port. Take the receiver to the base plate using double tape. Now connect a micro USB cable to the LED module and also connect the battery. Turn on the radio and make sure it is bonded with the receiver. Connect the USB cable to the laptop. This is DJI NAZA-M V2 assistant software. I will provide a link for this in description below. Here you can see the LED is blinking. This means our flight controller is perfectly connected with the software. I'll skip the update for now. Let's go to basic settings. Here you can find all types of common frames. Some hexacopter, octacopter, quadcopter. This is our required frame. Just click on it. Now move to the mounting section. Here we will tell the flight controller where our GPS is mounted. This is the x-axis. The red line indicates the negative value and green line indicates the positive value. As our GPS is mounted in front of our flight controller, this means our x-axis will be in positive, while the right side represents the positive value and left side represents the negative value of y-axis. Upside represents the negative and downside represents the positive value of z-axis. Now we will need a scale to measure all these values. Here you can see I am using a scale in centimeters. The x-axis looks 5 centimeters, while the y-axis is 0 because the GPS is in the center. The z-axis looks 15 centimeters. Now let's input all these values. As x-axis is in forward, so it will be positive 5. So here we will input 5 and hit enter. As the GPS is in center, so the y-axis will be 0. So here we will input 0. As the GPS is above the flight controller, this means the value will be negative. So here we will input negative 15. Hit enter to save all the values. Now let's move to the RC section. Traditional mean PWM input. It also supports PPM input, but we are using S-bus, so we will click on D-bus. Now you can see all the sticks are perfectly moving. Mode switch is also perfectly moving. Let's start the calibration process. Move all the sticks to the endpoints. After that, hit finish and OK. Now let's calibrate the mode switch. Here is a twist. Actually, this stick is not always on GPS. It always comes out of the range. Not just for the GPS but also for altitude and fail-safe. It always comes out of the range. We need to adjust all of them by trimming the values. And it is also necessary for the compass calibration. We can trim it like this. If you are using the same radio, then you can follow these steps. Put these same values on your transmitter. Minimum -67 and maximum 62 and ppm center must be 16. That's it. This is a tricky but very important part. because for the compass calibration we need to switch continuously between GPS and altitude mode. After setting these values you will get the same result. Here just set it to the default. Now move to the advanced setting. Here always use recommended. And cutoff time always intelligent. Fail safe, always set it to the return home and land. Flight controller also has an orientation lock. This is an extra feature. If you want you can use it, but for now I am not using it. We are not using gimbal, so skip these steps. Voltage part, this is also very important. We are using a 4S LiPo battery, so we will select 4S LiPo. We also need to calibrate the voltage. Just use a voltmeter to check the voltage and input here. I will be using this voltage sensor. It's showing 16.2. It's already here 16.2, so I will click OK. Now on tools, this is very important part. This keeps the drone stable. Place the drone at a highly level surface. Click on basic calibration and click on yes. Basic calibration is done. Now go to advanced. Click on advanced calibration and click on yes. Again click on yes. Temperature of microcontroller is too high. This line always appears. Just click on yes and no need to worry. Wait for 5 to 10 minutes until the advanced calibration is completed. While the advanced calibration, do not touch or move your drone. Here the programming part has been completed. Check updates, no update. Close the software and disconnect the USB cable. Before moving to the next step, we need to fully charge our battery. So for that, I will be using IMAX B6 AC charger. This charger can charge 2 to 6S LiPo battery with up to 6 ampere. Connect all the cables to the charger. Turn on the power supply and connect the battery. Make sure to connect this connector on 4S port. Select the battery ampere and battery S and start the charging process. Hit enter to start the charging. After the battery fully charged, now we need to go outside for the compass calibration. Because inside the lab there is too much magnetic interference. Here we are in the open space. Connect the battery and also turn on the radio. Here you can see LEDs blinking in different pattern. Move the mode switch up and down multiple times until the LED becomes constant. Here you can see the LED become constant. This means it is ready for compass calibration. Move your drone as I am moving. Now you can see the LED become green. This means we need to nose down our drone and move 360. Now when LED start blinking, this means the calibration has been successful. Now center both the sticks to arm. You can see it is successfully armed. Raise the throttle will rise in speed of the motors. Now it's fully ready to fly, so let's apply propellers. I will be using 10 inches of propellers. Apply the propellers as I explained and make sure to tighten all the screws. Now let's test its first flight. Arm it and slowly raise the throttle. The drone won't move until the throttle is 50%, but rising more than 50% it will automatically lift. Here you can see it's really stable and easy to fly. You can see guys, no one is controlling it. And you can see it's really very stable. I haven't seen a custom made drone having such a stability. Please make sure to like, subscribe and press the bell icon so that you can get the notification of our latest video. Till then, take care and see you soon.